Today we are going to take the miscellaneous exercise on the determinants chapter. So first of all we need to see the four five examples are there. Out of that some examples are very easy, some of them are very difficult. In between of this exercise I'll just tell you which is very difficult and I'll do one of those questions, and some of the questions are very similar to the one of the exercise questions also. Okay, that's why I'm going to start with the exercise now itself. So we'll see the first question now. The first question here is, you need to prove that the given determinant is independent of theta. What is the meaning of independent of theta? The determinant is a value, as we know. So if it has to be independent of theta, that means there should be no theta in the value of the determinant. So the direct simple meaning of this question is, you are asked to evaluate this determinant and show that it is not having any theta term. That's it. So we'll just expand this. We can expand using any one. So maybe I'll expand using the third row. So it is going to be cos theta into sin theta minus x cos theta. Okay, that was the first term. Then you have minus 1. 1 is there. So since it is the second position, I need to take on minus sign. So minus 1 into x plus sin theta cos theta. Okay, then you have an x remaining plus x into minus x square plus sin square theta. Okay, we'll see what is going to remain over here. Is it alright? Plus x into minus x square plus sin square theta. It's alright. So the remaining part of this question is just to evaluate or go on simplifying this line. So this is cos theta sin theta, then you have minus x cos square theta. Okay, then you have minus x, then minus sin theta cos theta. Okay, then you have minus x cube plus x sin square theta. Is it alright? Okay, it had to be plus here, right? That was the problem. It had to be plus here. So this term becomes plus. So we can find out that here plus cos theta sin theta and minus cos theta sin theta, I can just cancel this off. If I cancel this off, what is the remaining things is? So we are asked to find that, show that it is going to be independent of theta. So we have no problem with these two terms. They can be there over there. So what is the next part? Okay, we'll just think about the trigonometric identities for solving this. Because it is sin square and cos square theta, I take x common outside. Okay, I'll first of all write what is remaining here, minus x and minus x cube. Then I take x common out of these two and write cos square theta plus sin square theta. Cos square theta plus sin square theta was 1. Therefore I get minus x cube plus x into 1. So minus x and plus x will get cancelled. You get minus x cube as the answer. So minus x cube has only x term, no theta term. So therefore you can tell that the determinant value of this is independent of theta. That's all about the first question. So the next question is, without expanding the determinant, we are asked to prove that this is the left hand side and this is the right hand side. We are asked to prove that left hand side equal to right hand side by using properties, right? It is given without using the direct expanding. So we are asked to prove using the properties. So first of all, see in the first line we'll see the right hand side now. First line we have a only. We'll leave that one over there. We have only a terms, here only b terms and c terms. So here a term is missing, here b term is missing, here c term is missing. Okay, we have no problem with the second column here. The first column somehow we need to change later. So we need to bring one a here, one b here, one c here. That's all we need to do. So I'll multiply the first row with a, second row with b, and the third row with c. So if I multiply each row or column, by a factor. Okay, it can be any scalar factor. So I need to divide it by this, because if I multiply each determinant, each row of a determinant, the value of the determinant becomes k times that. Okay, it was a property, right? So I need to cancel that off. So I write 1 by ABC first, then this becomes a square since I multiplied one a to the whole column. So this is a cube and this becomes ABC. Similarly, if I multiply b with the second column, this becomes b square, this is b cube, this is ABC. Okay, then you have c square, c cube, ABC. Okay, whenever we see something common in one column, we should always remove that. Okay, we have ABC common from C1, so we need to remove that. So ABC divided by ABC. Okay, this was ABC which I removed from the column. This ABC is whatever is here. So this becomes a square, b square, c square, a cube, b cube, c cube, 1, 1, 1. Okay, this much we got. So this is cancelled, however. Now we need to just see the remaining part, what is going to happen. So we have 1, 1, 1. Okay, correct. A square, b square, c square, a cube, b cube, c cube. But it is not in the proper order. So we need to just rearrange that. So the properties say that if you interchange any two rows or columns, the change in the sign of the determinant takes place. So if I change any two of these, the sign will change. So this should go here, right? So C1 is going to change to C2. Okay. That time what will happen? We put one minus sign here. So this is a cube, b cube, c cube, a square, b square, c square, 1, 1, 1. Okay. So this column should come here. So C1 interchanging with C3. Again one more minus sign comes here. One minus sign was already there. So I can cancel that off and write only one positive thing. That becomes 1, 1, 1. A square, b square, c square, a cube, b cube, c cube. Okay. That's all about this second question. So we are just asked to use without expanding. That means we need to use the properties. Okay. So the property we use here is, first we need to multiply each row. If I multiply each row by one thing, so the whole determinant gets multiplied by that. In order to cancel that off, I use this 1 by ABC. Since ABC was common out of the one column, I removed that ABC and this got cancelled. And the next thing, I was just rearranging those things. If I had to interchange any two, there was a negative sign. But I interchange once more, that's why that minus sign also got cancelled. So this is equal to this, LHS is equal to RHS. That's all about the second question. Next we'll move on to the third question. Okay, now we have the third and the fourth question. So the third question is direct. It is given, you need to just evaluate this determinant and find out what is going to be. So we have so many terms. So maybe easier one I'll try to find out, however. So how do I start? Let me start with the second. Okay, second row I'll start. Sine beta into cos square alpha sine beta. Okay, then we have plus sine square alpha sine beta. Okay, then we have plus cos beta. This comes to be cos square alpha cos beta. Okay, then plus 1 minus is there, so I made it plus. So sine square alpha sine, no, cos beta. Yeah, cos beta, right? Cos beta. Okay, so we'll take sine beta common item here. So this becomes sine square beta into cos square alpha plus sine square alpha. Okay, then we have plus here cos beta I'll take common. So this comes to be cos square beta into cos square alpha plus sine square alpha. Okay, Cos square theta plus sin square theta is 1. Therefore, this whole thing becomes 1 here also. Then we have sin square beta plus cos square beta. Okay, so it becomes sin square beta plus cos square beta. Okay, this is also 1. Therefore, 1 is the answer for this. So it was a very simple question. So you need to just take care from where we need to start. Because since we have a 0 over here, I started with here. If you are going to start with the third column, it's going to be more problematic because it is going to be like this. So you are going to get cos theta, sin theta, cos beta, blah 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 blah. So many things you get. So that is going to be very irritating. So better you need to take care which one you are going to start with. Okay, that's all about this question. Next we'll move on to the fourth question. So fourth question here given is, if A, B, C are real numbers and this is the determinant is equal to 0. Okay, it is given, you need to show that either A plus B plus C is equal to 0 or A is equal to B is equal to C. Okay, this is a easy question and common question, very long, but the main thing is you need to check what is the condition over here. If A is equal to B equal to C, how the condition arises. That's all about this question. So we'll see. We also have an example very similar to that. That is example 30. Okay, but the framework of the question is different over there. Here it is different. At last we'll end up with the same thing. So we'll just take the left hand side and simplify. At last we'll equate it to 0 and get whatever we want. Okay, in the example 30 it was given that it was negative, right? It was given negative. There the condition was different, that it was positive real numbers. Yeah, it was positive real numbers. Here just real number is given. Okay, because that doesn't make a matter over there. So now here what we are going to do. First of all, we need to get A plus B plus C as one of the terms. So we do not have anything like that. Okay, A plus B plus C is a long term. So first of all, we need to remove that such that we get a simpler determinant. So for that, we are going to add all the rows or the columns. Maybe I'll add all the rows. So R1 becomes R1 plus R2 plus R3. Okay, so this is going to be 2 times A plus B plus C, 2 times A plus B plus C, 2 times A plus B plus C. Okay, this is going to remain the same. C plus A plus B, B plus C, A plus B, B plus C, C plus A. Okay, so now we'll remove the 2 times A plus B plus C. I hope how you got that 2 times A plus B plus C. Add all the 6. So you are getting 2A plus 2B plus 2C. That is 2 times A plus B plus C. So I am going to remove 2 times A plus B plus C here. That is 1. C plus A plus B. 1. A plus B, B plus C. 1. B plus C, C plus A. Okay. Now we got 1 by 1. Okay. The remaining thing, whenever we use the property, is this thing getting 2 zeros. If we need to get 2 zeros, what we need to do? We'll take C2 becomes C2 minus C1 and C3 becomes C3 minus C1. Okay, so this is 2 times A plus B plus C into, this column remains the same, A plus B here. Okay, we need to subtract the second column from the first. So we had to get 2 zeros, right? Somehow we got 2 zeros. That's all. Next thing is A plus B minus C plus A. That becomes B minus C. Then we have B plus C minus A plus B. B and B get cancelled. You get C minus A here. Okay. Then what we have here is B plus C minus C plus A. C and C get cancelled. You get B minus A. Okay. Then we have C plus A minus A plus B. You get C minus B. Right? Is it all right? C plus B? Yeah. C minus B. Now the remaining thing is just evaluate the thing. Okay, we'll get 2 times A plus B plus C into, what are we going to get? So we'll expand using the first row. 1 into B minus C into C minus B plus A minus B into C minus A. Okay, we'll just expand this and see what we are going to get over here. So 2 times A plus B plus C, and this is going to be BC plus BC minus C square minus B square. That was the first one. Second one is plus AC minus A square minus BC, then plus AB. Okay, this many terms we got. So 1 BC we can get cancelled. So what is remaining over here is C square, B square and A square, AC, BC and C, AB terms. Okay, so I think one negative sign we can remove over there. So what is the condition given? Second condition. So if I directly equate it to the 0, we are going to get A plus B plus C is equal to 0 and this whole term is equal to 0. So this is going to be very irritating. So we need to simplify this somehow. Okay, how we are going to simplify? That is this similar to the example 30. So even in example 30 you are going to get like this only, but there 2 will be missing. That is the only difference, 2 will be missing. So we are going to remove one minus sign from there and take this 2 inside. So it is going to be 2a square plus 2b square plus 2c square minus 2ab minus 2ac minus 2bc. Okay, this much we are going to get. So it is given A plus A is equal to B is equal to C. If I take only one condition, A is equal to B, that means that A minus B is equal to 0, right? Or I can tell B minus C is equal to 0 and A minus C is also equal to 0. So those 3 conditions we need to get from this one thing. So we'll see how we are going to get that. So this is minus of A plus B plus C. Okay, so I'll just expand this and write A square and B square. I want A minus B whole square term such that I can tell that condition if A square and minus 2AB plus B square, that is the first one. Second one is plus B square minus 2BC plus C square, that is the second one. Then we have plus C square minus 2AC plus A square. Okay, we have used all the terms now, right? This is all right. So this is going to be minus of A plus B plus C into A square minus 2AB plus B square is same as A minus B whole square. So I'll write A minus B whole square plus, then we have B square minus 2BC plus C square, that is B minus C whole square. B minus C or C minus B, anything you can write, B minus C whole square. Then similarly we have C minus A whole square. Okay, this much we got, right? That's all about this. Now equate it to 0. I'm going to equate it to 0 as per given in the question. If I equate it to 0, that means that these 2 terms are 0. That is A plus B plus C is equal to 0 and A minus B whole square plus B minus C whole square plus C minus A whole square is equal to 0. Okay, so this was one of the conditions I think we have already dealt with. So if you are going to add any squares, every square is at least 0. Okay, if you are considering the function x square, its range is going to be from 0 to infinity, right? So we can say that the minimum value of each of them is equal to 0. Since the sum of all the 3 is equal to 0, that means that each of them is also equal to 0, right? If each of them are going to be equal to 0, that means that A minus B whole square is 0 or A minus B is equal to 0. Okay, from here I come to be A minus B is equal to 0, then B minus C is equal to 0 and C minus A is equal to 0. Okay, that means that A is equal to B, B is equal to C, C is equal to A. Or I can write a condition, that is A is equal to B is equal to C. That is a condition. So have you understood how I got that A is equal to B equal to C? So we have somehow got the simplified term by seeing these steps. So I got A minus B whole square plus B minus C whole square plus C minus A whole square is equal to 0. If the sum of the squares of them is equal to 0, then all the squares should be equal to 0. That is a condition over there. So A minus B is equal to whole square is equal to 0. If the square is 0, the whatever is there, number inside is also equal to 0. Therefore, A minus B equal to 0, B minus A is equal to 0, C minus A is equal to 0. So that you can see the condition. That means that all these three are equal. That's all about this fourth question. In the example 30, you have all the things similar over there. But in that it is, what is the question given over there is, the value of the determinant is negative. The step is going to end here. Okay, it is not going to be equal to 0 over there in the question. So it is given that the value of the determinant is going to be negative. It is given that they are positive and real, and they are not going to be equal. A is not equal to B and not equal to C. So if they are not equal, this term cannot be 0, right? That term cannot be 0. Since it is given that they are going to be positive, all the three terms are positive and unequal, that means that this also cannot be 0, right? There one extra half you are going to get. That's the difference between this and example 30. In example 30, at last you will land up minus half into A plus B plus C into A minus B whole square plus B minus C whole square plus C minus A whole square. Okay, that's all the thing. So this cannot be 0 if they are unequal. This cannot be 0 if they are positive. So the remaining thing is only one negative sign. So the question in the example 30 was, you need to prove that the determinant is going to be negative, value of the determinant. So this negative sign indicates that the determinant value is going to be negative because the sum of the squares cannot be negative. Since they are positive, their sum also cannot be negative. That's all about this fourth question and example 30. Okay, next we'll move on to the fifth question now. Okay, now we have our fifth question. In the fifth question, we are asked to solve for x. It is given that A is not equal to 0. So what is the problem if A is equal to 0? So if A was equal to 0, then this whole row and the column is going to be x, x, x. And even this row is going to be x, x, x. Since two rows are going to be equal, it could be 0. If A was equal to 0. Okay, that was a condition. So if A is not equal to 0 is the case given here. So what is it going to be? We will do one thing. We are going to add all the rows and the columns, or all the rows and add. R1 becomes R1 plus R2 plus R3. So this is going to be 3x plus A, 3x plus A, 3x plus A. This is x, x, x plus A, x, x, x plus A. Okay, this much you got. Now the remaining thing is removing 3x plus A outside. If I remove that, there is going to be 1x, x, 1x plus A, x, 1x, x plus A. Okay, now we need to get two zeros. For that, we'll change C1 to C1 minus C3 and C2 to C2 minus C3. So 3x plus A is remaining over there itself. So it is going to be 0, 0 here. This is as it is, x plus A. Okay. Then we have, this is also 0 now. This changes to minus A here. This changes to minus A. This changes to A. Okay. Now we will just expand this. I'll expand this using the first row. This is 3x plus A into 1. Okay. 1 plus A square is equal to 0. Okay. Not 1 plus into A square. Okay. 1 into A square is equal to 0. A square is the value of the determinant. So either A square is equal to 0 or 3x plus A is equal to 0. That means A is equal to 0 or 3x plus A is equal to 0. It is given that a is not equal to 0, so this condition is cancelled. So you get x is equal to minus a by 3 as the answer. That's all about this question. Moving on to the sixth one. Okay, now we have our sixth question. Sixth question is very simple. You can just prove this left hand side is equal to right hand side. So first of all, we need to remove a, b, c common. So a was common in this first column, b from the second, and c from the third. So I removed one a, b, c outside. So what it is going to remain is a plus b, b. Okay, c, b, b plus c. This is a plus c, a and c. Okay, this is what is going to remain. So the remaining is very simple, I think. We are just asked to prove 4a square, b square, c square. So a, b, c we got. So only 4a, b, c is remaining. So somehow we need to get that. So for that I'll use one of the operations. So I'll take r1 becomes r1 minus r2 minus r3. Okay, so this becomes a minus b minus b, so it is minus 2b is coming here. So this side will remain as it is, b plus c, and c will remain as it is. So c minus b minus, so minus 2b is remaining here. Okay, 0 remains here. Okay, that's all about this one. So I can remove minus 2b. So this becomes minus 2b into abc, 1 1 0. Then a plus b, 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 a, b plus c, c. Okay, that's all we got now. So we'll see what could be done for the later part. So one more 0 I want to get. So I'll take c2 becomes c2 minus c1. So if I change like that, it is going to be minus 2b square ac. Okay, then the first column is remaining as it is, that is 1 a plus b and b. Okay, here last column also remains the same, 0 a c. So what will be about the second column? 1 minus 1 becomes 0. Then we have b minus a minus b. So minus a is remaining. Then you have b plus c minus b. Therefore c is remaining. Okay. So you have minus 2b square ac into minus ac minus ac. Okay, that is same as minus 2b square ac into minus 2ac. Minus and minus get cancelled. 2 into 2 is 4. 4a square b square c square. That is what is the right hand side. That was what was required. That's all about the sixth question. Moving on to the seventh one. Okay, now I'm going to start with the seventh question. We'll see what is given in the seventh question now. Seventh question, A inverse is given and B is given. You have to find AB whole inverse. Okay, so there is a property AB whole inverse is equal to B inverse into A inverse. Okay, you can use that, or you can find the inverse of this first, then find AB and find again the inverse of AB. Any method is better, is for you, you can do that. So for me, I think using the property is more favorable because I need to find inverse only once. So I need to find B inverse. For that, I need to find adjoint of B and at B. So first of all, I'll find adjoint of B. What is adjoint of B? It is a transpose. It is a transpose of the cofactors of the particular elements. Okay. So now you have, for this particular element, you'll have 3 here. Okay. Then corresponding to this, you'll have minus 1. So since it is this position, plus 1 it becomes. Now you consider this position, that is minus 1 into minus 2, that is going to be 2. Okay. Then in this position we have 2 into 1, that is 2. Then minus 2 into minus 2 is plus 4. So 2 minus 4 is minus 2. Since it is this position, I need to make it plus 2. Okay. Then we have in this position 1 into 1, that is 1 only. Okay. 1 more here, that is 1 into minus 2, that is minus 2 only. Then Since it is this position, I need to make it plus. Then corresponding to this point, that is 2 into 0, okay, 3 into minus 2, okay, 3 into minus 2 is minus 6, negative of that is plus 6, okay, that means we got. Now this position is minus 1 into minus 2, that is 2 only. Since it is this position, 1 minute, minus 1 into minus 2, that is 2, there should be minus of that because 0 minus 2, so it is minus 2 over here. Since it is this position, I made it plus. Now we have last one, 1 into 3, that is 3 minus of minus 2, 3 plus 2 is 5, okay, so you have 3 1 2 2 1 2 6 2 5, okay. Now we are going to find the determinant value of b. What is going to be the determinant value of b? So we already have the cofactors here. I need to multiply with the particular elements. So it is 1 into 3 plus 2 into 1 minus 2 into 2. Okay, 1 into 3 is 3. 3 plus 2 is 5. 5 minus 22 is 4. So 5 minus 4 is 1. Therefore, determinant value is going to be equal to 1. So what is B inverse? B inverse is same as adjoint of B because B inverse is adjoint of B divided by det B. Since det B is 1, I can just leave it out. Only adjoint of B is going to be equal to B inverse. So what is B inverse into A inverse is same as AB whole inverse. So for finding AB whole inverse, I'll find out B inverse into A inverse. So first of all, I need to write this. That is 3 2 6 1 1 2 2 2 5 into 3 minus 15 5 minus 1 6 minus 2 1 5 no, minus 5 2. Okay, so you are going to get a 3 by 3 matrix only at last because it is both are 3 by 3 matrices. So 3 into 3, that is 9 plus 2 into minus 15 is minus 30. 6 into 5 is also plus 30. So those two get cancelled and what is going to remain is only 9 here. Okay, now we have 3 into minus 1, that is minus 3. Minus 3 plus 6 into 2, minus 6 into 2. Oh, again, it is going to be only the first one, that is 3 into minus 1. Okay, that is minus 3. Right? Yeah, minus 3. Next we have 6 into 1. 6 into 1 is 6. Then minus 3 into 1, right? 3 into 1 minus 2 into 5. Okay, something we are doing it. 3 minus 10. 3 minus 10 is minus 7. Minus 7 plus 6 into 2 is 12. Minus 7 plus 12 is 5. Okay, we are going to get 5 over here. Now the next thing here in this position. So second row, first column, 1 into 3 minus 15 plus 10. Or 13 minus 15, I can write minus 2 as here. Okay, then for second row, second column, minus 1 plus 6 minus 4 or minus 5 plus 6. Minus 5 plus 6 is 1. Okay, then we have second row, third column, 1 into 1. 1 minus 5 is minus 4. Then minus 4 plus 2 into 2 is 4. So again 0. Then in this position we have, so it is third row, first column, 2 into 3, that is 6. 6 minus 30, that is minus 24. Minus 24 plus 25. So 1 we are going to get here. Now think about this position, second row, third row, second column, 2, it becomes minus 2. Minus 2 plus 12. Minus 2 plus 12 is plus 10. 10 minus 10 is 0. Okay, 5 into minus 2 is also 10, right? Now, third row, third column, 2 minus 10 is minus 8. Minus 8 plus 10. Okay, again we are getting 2. So this is the answer. Or I can tell AB whole inverse is equal to this particular matrix. That's all about the 7th question. Moving on to the next. Okay, now we have our
10th and 9th and 10th question. The 8th question was very simple because it is just based on the property that is inverse of the adjoint is going to be adjoint of the inverse, or A inverse whole inverse is equal to A. That is very simple and direct. You can just verify. Somehow you need to get the left hand side is equal to right hand side. Okay. Now the next question is the 9th question. In the 9th question and the 10th one, you are asked to evaluate the given determinants. So what we need to do? So evaluation, you can make it in very simple manner. Instead of if you just directly evaluate it like this or expand this, you can get so many terms and they'll get cancelled, and at last you need to get a simplified answer. So that's why we are going to use the properties instead of just expanding there itself. So R1 I'll convert it into R1 plus R2 plus R3. Okay, if I add all the rows, I'm going to get 2 times x plus y everywhere. 2 times x plus y, 2 times x plus y. Okay, that is here you are going to get y, x plus y here, x, then y. Okay, so we'll remove 2 times x plus y here. Okay, then what is remaining here is 1, 1, 1, y, x plus y, x plus y, x, y. Okay, this is what is going to remain. So we'll see how we can simplify. So already we know the method of simplification, because when 1 is coming in a particular row or particular column, we are going to subtract and get it 2 zeros out of that. That is the same method we are going to use here also. That is C2 to C2 minus C1, C3 to C3 minus C1. Okay, that is 2x plus y is there itself. Then we have the determinant. So first column is as it is because we are not going to disturb it. So these 2 zeros we are going to get x plus y minus y is x. Here we are going to get x minus y. Here we are going to get minus y here, and y minus x minus y. So y and y cancels, only minus x remains. Okay, we just expand this, that is 2 times x plus y into 1. I'm expanding using the first row. So 1 into, what is going to remain is minus x square, then plus y into x minus y. Okay, we'll just simplify. 2 times x plus y into, what are we going to get? Minus x square, then minus y square plus xy. Okay, this is a direct format. We know one of the things that is of this format, that is a cube plus b cube, right? A cube plus b cube is equal to a plus b into minus a square minus, okay, 1 minus is extra, I think, right? So 1 minus will remove. We know that it is a plus b into a square plus b square minus ab is equal to a cube plus b cube. So we'll remove one minus sign out. So it is going to be minus 2 into x cube plus y cube. Okay, x cube plus y cube, because we know the term that is a cube plus b cube is going to be equal to a plus b into a square plus b square minus ab. Okay, one minus sign we removed from this bracket, so we got one minus sign outside. So the simplified answer is going to be minus 2 into x cube plus y cube. That's all about the 9th question. Most simplified answer. Next we'll move on to the 10th one. 10th one is also about just simplification. We'll see how we can do this. Since we have 1 already in a particular column, we are going to use the same method how we used here. So here it was column operation. Here we use a row operation because the column has ones. So R2 becomes R2 minus R1 and R3 becomes R3 minus R1. Okay, we'll see. This becomes 1, 0, 0. The first row remains as it is. X plus y minus x is equal to y. Y minus y is 0. X minus x is 0. X plus y minus y is going to be x. Okay, so just expand using the first column.
So you are going to get 1 into yx, or I can just write it as xy.
xy is a thing. So if you hadn't done this elementary operation, then it would have been so irritating, right? If you just go on x plus y whole square, then xy, then so many terms you're going to get. So instead of doing that, just use property over there. This was very easy, right? Next, we'll move on to the 11th. So the set of questions from 11 to 15 are about proving without expanding. Okay, now we have our 11th question. We're asked to prove that LHS is equal to RHS. RHS have written like this. So somehow we need to get in this format. So you're asked to do without expanding using the properties of the determinant. So since I have a thing like this, alpha, beta, gamma, so better I'm going to do it with like this. So C3 becomes C3 plus C1. Since I have a term that is remaining, so you have gamma plus alpha, 1 beta is remaining like that. Similarly you have over here. So what we are going to get is here alpha, beta, gamma, then alpha square, beta square, gamma square here. Then here alpha plus beta plus gamma you will get alpha plus beta plus gamma, alpha plus beta plus gamma. Okay, so we can remove an alpha plus beta plus gamma outside, and we are going to get alpha, beta, gamma, alpha square, beta square, gamma square, 1, 1, 1. Okay, this is the most commonest thing. I think at least one of the questions you have seen such of things. So I am going to do it faster now. R2 becomes R2 minus R1, and R3 becomes R3 minus R1. So when I do that, I am going to get 2 extra zeros. So alpha plus beta plus gamma is already there. Okay. So for the first row remains as it is, that is alpha, alpha square and 1. Okay. So this was beta minus alpha, gamma minus alpha, gamma square minus alpha square, 0, 0, beta square minus alpha square. Okay. Since we need that beta minus gamma, gamma minus alpha and all, so the one thing we can do is we can remove the factors first of all, and rather than expanding and doing all those things, so we'll use alpha plus beta plus gamma here. Okay, we'll remove beta minus alpha from here, beta minus alpha from the second row. The third row I'm going to take gamma minus alpha. Okay, so what is gamma minus? So you have alpha, alpha square and 1, that is already there. Then you have 1 here remaining. Here alpha plus beta is remaining. Here 2 zeros. Here you are going to remain with alpha plus gamma, and here also 1. Now we can expand using the third column. So these 3 terms are going to be there itself. So I put one into mark here. So it is 1 into alpha plus gamma minus alpha minus beta. That is alpha and alpha you can cancel. So it is gamma minus beta. Okay, gamma minus beta we got. So it is beta minus gamma given here. But why did I get gamma minus beta? That was because of one of the sign difference. Here I had to get alpha minus beta, but I got beta minus alpha. If I multiply minus 1 to both of these factors, we are going to get this right hand side. That's all about the 11th question. Okay, next we'll move on to the 12th question. You can just refer the example 15. In the 12th question, they are just given an extra p over there, p factor that is present over there. So just you can refer the method in the example 15 itself. It is exactly the same, extra 1 p is mentioned. Then we have the 13th question. 13th question is like this. So you are asked to prove that it is equal to 3 into a plus b plus c into ab plus bc plus ac. Okay, what we are going to do now is somehow to get the a plus b plus c. Okay, for that we should add all the columns. So we'll add all the columns to the first column. So it is going to be c1 becomes c1 plus c2 plus c3. Therefore this is going to be 3a minus a plus b minus a plus c. That is going to be a plus b plus c. Similarly you are getting a plus b plus c here also. can just check how it is, because you have 3b and 2 negative b's. Okay, here also you have 3c and 2 negative c's, so you are going to get a plus b plus c. The remaining things is as it is, minus a plus b, 3b, minus c plus b, minus a plus c, minus b plus c, 3c. Okay, this much we got. So we can remove one a plus b plus c outside. A plus b plus c outside. It becomes 1, 1, 1. And we have minus a plus b, 3b, minus c plus b, minus a plus c, minus b plus c, 3c. Okay, that much we got. Now the remaining thing is I need to get 3 times ab plus bc plus ca. So I don't think I can get a factor out of that. So at last maybe we can land up at that thing. So we'll just check whether we are going to get a 3 somewhere. No, we are not going to get a 3 over there anywhere. So we'll see a plus b plus c here itself. And since we got in this format the same 2 operations, I am going to apply over there also. Same 2 operations, because I have got 1, 1, 1. Here also I have got 1, 1, 1. Somehow I need to get 0. So the first row remains as it is, 1 minus a plus b minus a plus c. Okay, these 2 become 0. Then this is about 3b, that is 2b plus a. This becomes 2b plus a. Then this is minus b plus a. Then this is minus c plus a, and this becomes 2c, 2c plus a. 2c plus a. So everywhere that a has come from nowhere. Okay, we'll see what it is going to be. That is a plus b plus c into, we'll just expand using the first column. So it is going to be 2b plus a into, okay, I'll do it this side so that I have got more space. We got a plus b plus c already. So the remaining thing is 2b plus a into 2b plus a into 2c plus a minus of a minus b into a minus c. Okay, I'll just rearrange and put that a minus b into a minus c. So we'll see what it is going to be. A plus b plus c is as it is. Then we'll just expand this. Okay, if we expand this, we are going to get 4bc, then 2ab, then 2ac, then plus a square. Okay, so somehow we need to get that format, right? So somewhere we are going to get added. So minus of a square minus ab, then minus ac plus bc. Okay, or I can just change the sign everywhere. This becomes plus, and this becomes minus. Okay, I just put that inside. So if I do that, a square and a square got cancelled. Then yeah, we'll see what it is going to be. A plus b plus c into 4bc minus bc is 3bc. Then we have 2ab plus ab, that is 3ab. Then 2ac plus ac is 3ac. So we'll take 3 common outside. You're going to get 3 into a plus b plus c into bc plus ab plus ac. Okay, that was the thing we had to get. So I hope you understood. Here was the step that we done in the previous question also, 11th question, because we had got the 1, 1, 1. So to get 2 zeros, we had done the elementary operations. From that, we just expanded this and got the simplified answer to be this one. That was all about the 13th question. Moving on to the 14th. Okay, now we have our 14th and the 15th question here. So the 14th question is like this. You are asked to prove that this determinant is going to be equal to 1. That means all these p and q terms are going to be gone. I don't know where, somewhere it will go. We'll do something. Wait something, yeah. This 2p somehow I need to get removed. This 3p also I'll get removed somehow. We'll see what will be remaining over here. So for that I need to do R2 becomes R2 minus R1 and R3 minus 2R1, okay, because there is only 1p here. So R3 to R3 minus 3R1. We'll see what it is going to be. This is going to be 1 plus p and 1 plus p plus q itself, okay. Then 2 minus 2 times 1 is 0. Similarly this also is 0. Then you have 6 plus 3p. 6 plus 3p minus 3p and 3p will get cancelled. 6 minus 3 you will get 3, okay. Then 3 minus 2 you will get 1 here, okay. Then what is going to remain here is 4 minus 2 is 2 plus 3p minus p is 1 more p you will get. Then 2q minus 2 times this thing, right? Therefore it is going to be, that much is done. Then 10 minus 3 times this, that is 7 plus 6p minus 3p, that is plus 3p. 3q minus 3q, that q will go, okay. We'll see what is going to remain. Now the remaining thing is about expansion. Expansion is in the first column. So it is going to be 7 plus 3p minus 3 times 2 plus p, okay. That is 7 plus 3p minus 6 plus 3p. So 3p and 3p cancelled. You're going to get 1. That's all about the 14th question. See, I hope how you understood that it is going to be 2 times R1. Yeah, similar to that elementary operation we used using for the matrices and all. So now we'll move on to the 15th question. So 15th question is all about trigonometric identities. You are asked to prove that this given determinant is going to be equal to 0. So for that we are considering that delta is going to be equal is some constant, okay. It's not a variable, it is a constant. So okay, I'll just show the expansion of cos of a plus b here. Cos of a plus b, because I have alpha plus delta over there, somehow I need to get that expansion instead of somehow I need to get 0. That means that either all of the thing that is present in one column is going to be equal to 0, or maybe that 2 columns are going to be equal, or 2 rows or something is going to happen. So cos of a plus b is same as cos a cos b minus sin a sin b, okay. So this much we got, yeah. So we have cos a and cos b. If it was alpha and delta, this could be cos alpha cos delta minus sin alpha sin delta. So sin alpha we have here, cos alpha and we have in the second column. So we are considering sin delta and cos delta because they are constants. So I'm going to multiply something. So we can't do with the third column, right? The third column becomes C3 minus cos gamma, not gamma, this is delta, cos delta into C, which is corresponding to the cos A, that is C2 minus sin delta into C1, not minus, plus, because you're getting a minus sign here. If you add that C1 into sin delta, you're going to get like that, okay. So I can directly write this. So since this is sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma, okay, we are going to get 0, 0, 0. This is just about the expansion of this. If I write this is going to be the expansion, you can just expand this. I have not written all the steps over here, So if you expand this, you are going to get cos alpha, cos gamma, cos delta. That is going to get cancelled with this term. Okay. Then we have minus sin alpha, sin delta. That is going to get cancelled with this particular term, which you are going to get here. So similarly about the other rows also. So you are going to get 0, 0, 0. So if a particular row or a column is going to be equal to 0, the whole determinant is 0. That's all about the 15th question. Next we'll move on to the 16th. Okay, moving on to the 16th question now. See, the 16th question here is given in the form 1 by x, 1 by y, 1 by z as the variables and not directly as the thing itself. So first of all, we need to get the value of 1 by x, 1 by y and 1 by z, and then we need to compute for the values of x, y and z. Since we have a system of linear equations, 3 linear equations in 3 variables, so we are going to get the matrix equation, that is a 3 by 3 matrix and all. So we are going to write the coefficient matrix now. That is 2, 3, 10, 4, minus 6, 5, 6, 9, minus 20 into the unknown matrix is 1 by x, 1 by y and 1 by z. This is very important. You write 1 by x, 1 by y and 1 by z, and the constant matrix is 4, 1, 2. Okay, so we have a x is equal to b. This was the format we used in the previous class. We learned how we had to solve and all. So we are going to find the inverse of a. For that we need to find the adjoint of this a. So let me mark this as a. So we find the adjoint of a. Adjoint of a is the transpose of the matrix having the cofactors of each element. So since it is a very big number, very big numbers, it is going to be very tedious work here. We need to be very careful. Okay, minus 6 into minus 20, that is 120. Okay, I'll just write here for referring 120. Then minus 9 into 5 is 45. Minus 45. So we will divide 5. 12 minus 4 is 8. So it's going to be 7. 75 is the first position. Next position. 4 into minus 20. That is minus 80. Okay. Minus 6 into 5. That is minus 30. Minus 80 minus 30, that is equal to minus 110. Okay, minus 110. Since it is this position, I need to change the sign. It becomes plus 110. Okay, next the third position. 4 into 9, that is 36. 36. Okay, minus of minus, that is again plus we are going to get. So plus 36, that is 72. 72 was here. Now the next term, 3 into minus 20, that is minus 60. Okay, minus 90. Okay, it is going to be 150 since I had to change the sign over there. Okay, next we have this position, that is 2 into minus 20, that is minus 40. Minus 40 minus 60 is minus 100. Right? Yeah, minus 100. Okay. So, next thing in this position, that is 9 into 2, that is 18. 18 minus 18 is 0. Therefore the 0 here. Okay, next we have one more thing here. Here we are going to get 3 into 5, that is 15. 15 plus 16, 60 is 75. So again 175 we are going to get. Okay, next this position, 2 into 5, that is 10. 10 minus 40, that is minus 30. Since it is that position, I need to change the sign. That becomes plus 30. Now the last position, 2 into minus 6, that is minus 12. Minus 12 again minus 12, it becomes minus 24. Okay, now the next thing is to find out the transpose of that. So what is the transpose of this is 75, 150, 75, 110 minus 100, 30, 70, no, 72, 0 minus 24. Okay, that's all we got here. We'll see what it is going to be now. We got the adjoint, now we need to find the determinant value. Okay, determinant value. However, it's going to be a very big number, I think. So, 2 into. So, multiply the element with a cofactor, you are going to get the value of the determinant. So, 2 into 75. 2 into 75 plus 3 into 110 plus 72 into 10. Oh, what big numbers? 150, 330, 720. Oh, 7 plus 3. Here you are going to get 1 in the first position. Okay, let me start with the last position. However, it is 0. Then 3 plus 2 plus 5 is 10. So 1 more carried. So 1 plus 1, 2. 2 plus 3. 7 plus 3 is 10. 10 plus 2. That is 12. So 1200 is going to be the value of the determinant over there. Okay, that's all about finding the determinant. The remaining thing is about multiplication. Okay. Next we need to find the value of the determinant. No, sorry, the matrix here. Ax is equal to b. So x is equal to A inverse of b. That is equal to adjoint of A divided by A into b. Therefore, 1 by 1200 into the big things. 75, 110, 72, 150 minus 100, 0, 75, 30 minus 24. Okay, this is the first one, and this is 4, 1, 2. Okay, so what is remaining now? The remaining thing is just to find the value 1 by x, 1 by y, 1 by z. For that, we need to multiply these two. Okay, we'll see the first row and the first column. So we are going to get like this, that is 1 by 1200 and a matrix like this. Because this is 3 by 3, this is 3 by 1. Therefore, we are going to get a 3 by 1 matrix. So there are 3 positions. The first position is first row, first column. Therefore, it is 75 into 4. So it becomes 300. Okay, 75 into 4 is 300. 300 plus 150. Plus 150. 300, 300, 600 you are going to get. Okay. Now the next part. 110 into 4. 110 into 4. Something you are going to get. What you are going to get? That is 440 minus 100 plus 60. Okay, minus 100 it becomes 340, right? 340 minus 60, sorry, plus 60, that is going to be 400. Okay, got it? 110 into 4, 440 minus 1 into 100, that is minus 100 plus 30 into 6, that is 60. So I'm going to get 400 here. Okay, then what about the last part? 72 into 4. Oh, so many numbers. Okay, I'll just run this. 72 into 4, this is 8 to 88. Okay, there's 0, very one nice number 0 came. Then we have minus 24 into 2, that is minus 48. So you get a 0 here. Then we have 8 minus 4 is 4. Then here it is 2. 240. Got a 240 here. So we'll see what is going to be the remaining things. this 1200 I'll take it inside. So it becomes 600 divided by 1200, that is going to be half. That is the first one. Second one is 400 divided by 1200, 0 0, both the zeros get cancelled, 4 by 12, or I can write to be 1 by 3. Okay, then we have 240 divided by 1200, 240 divided by 1200, 1 0 1 0 cancel, 24, 1 by 5 we get, 1 by 5. Okay, this is equal to the matrix 1 by x, 1 by y, 1 by z. Okay, so whatever is there in the denominator is going to be the answer. I'll write the answer here itself. The answer is x is equal to 2, x is equal to 2, y is equal to 3, and z is equal to 5. This is the answer. That's all about the 16th question. Before going to the multiple choice questions that is remaining, I will just like to solve one of the examples that is very nice. So let me start with that. Okay, now we have an example 32. This is a very long question, so we'll see how we are going to do this. So we need to get 3 terms of x plus y plus z. Okay, then x, y, z somehow we might get, that's very easy now. So first of all, maybe some x, y, z we can remove first because it's going to be irritating. And also we have y plus z whole square and x, y, x, z and all. So something we need to do for this. So the most commonest method we use is removing x and again putting x. Removing y, again putting y. So for that, we know that x and x, here the first row one x is common. Okay. And here you have y common and here z common. But here you do not have anything. The square terms are devoid of all the things. So we'll remove x. Okay. We'll multiply x, y, z to each row and each column depending on that. So first row I'll multiply by x, second row by y, and the third row by z. So x into y plus z whole square. Here you get x square y, x square z. Okay. Next you'll get here xy square, then y into x plus z whole square, then y square z. Okay, then we have xz square, then yz square, then z into x plus y whole square. Okay, this much we got. So from this column I can remove x. Since I multiply to the row, I need to remove from the column. Okay, that's the logic. If you just remove from the row itself, you are just undoing the same thing what we have done. So remain from this column, x, y, z we are going to get x from this column, y from this column, z from this column. So we are going to get y plus z whole square. Here you get y square, here you get z square, x plus z whole square, z square, x square, y square, x plus y whole square. Okay. Now we know the expansion of a plus b whole square. A plus b whole square is a square plus 2ab plus b square. So b square, a square and all will get cancelled because we have those things. So somehow we need to get those things cancelled. For that we need to use the elementary operation. So we'll convert R1 to R1 minus R2 minus R3. Okay. If I convert this like that, so we are going to get the determinant value. Here y square and z square will get cancelled and only 2yz remains. Okay. So we'll write the other two as it is. This is x plus z whole square. This is y square. This is x plus y whole square. This is z square. Okay, we need to just fill the other two. So x square, in this expansion you have x square plus z square plus 2. Okay. Instead of doing all those things, we have here x square and x square. So x square minus z square. So this is going to be complicated. So this method is not going to work in this place. Okay, we'll just think about something else. So what is going to be the step from the other two? So we'll just think about the columns now instead of the rows. So C2 becomes C2 minus C1 and C3 becomes C3 minus C1. So we get x, y, z mixed up because somehow we need to get it x plus y plus z over there. So x plus x, y, z we want. So this becomes so first column is as it is. We need to write it as it is, that y square and z square. Okay, this is going to be two big things here. That is x square minus of y plus z whole square. Then x plus z whole square minus y square. This is 0. Okay. Then again we have x square minus y plus z whole square. Okay. Then here you have 0. Here you have x plus y whole square minus z square. Okay, we need to be very careful in this. So we have square, 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 so many squares, so we're getting squares. So we need x plus y plus z. We have a square minus b square form. If I consider this whole thing inside the bracket as b, I can consider this is a square minus b square term. Similarly, we get here also a square minus b square. We know that a square minus b square is equal to a plus b into a minus b. So a plus b in every case is going to be equal to x plus y plus z. You can just see that a plus b is going to be the x plus y plus z term in both the cases. Sorry, all the 4 cases here. Okay, so we are not bothered about the first column because we have not done any operation over there. So we are going to write it as it is. That is y plus z whole square. Then y square and this is z square. Okay. Then if I remove x plus y plus z from the second column, what is going to remain is a minus b. Okay. Then here also a minus b, that is x plus z minus y, here 1 0. Okay. A minus b is going to remain, similar thing, that is x minus of y plus z, here 1 0. Then we have x plus y minus z, x plus y minus z. Okay, so we have taken out x plus y plus z whole square from the second column and the third column. Okay, that's all we got. So what is the determinant remaining is in this form. So we need to apply any of the row operations in order to cancel this off. For that, we'll take r1 to r1 minus r2 minus r3 in this case. Okay. Since I had seen in the first case that it would get cancelled and we get a smaller term here, I had chosen that. But seeing the second and third column, I felt that it had to be something like this. So the same step I am going to repeat it here, that is r1 minus r2 minus r3. Okay, so this becomes, so the second and the third row is going to be as it is, x plus z minus y, 0, 0, x plus y minus z. Okay, now we need to subtract this. So you are going to get 2yz here, 2yz term. And then we have x minus x is gone. Then minus y and minus y will be cancelled. So what is going to remain is only minus 2z. Minus 2z. Okay, then we have x and x, both will get cancelled. Minus z and minus z will get cancelled. So you are going to remain with only minus 2y. Minus 2y. So I think we can remove 1, 2 or let it be. You will see. So now what we are going to do is we are going to convert the second column. Okay, we are going to convert the second column. Somehow maybe we are going to remove this y here, we are going to remove this z here, so that we are going to get only the positive values. So to get the positive values, we need to do something with the first column. So the first column here, to remove this minus y, I need to add with 1 by y times the first column. Okay, 1 by y times the first column. I'll write that C2 becomes C2 minus 1 by y times the first column. Okay, that time I'll get rid of this minus 5 because it becomes plus y over there. So similarly, if I need to get rid of this minus z here, I need to multiply 1 by z to the first column and subtract from that. Okay, it's addition, right? Addition. So C3 becomes C3 plus 1 by z C1. Okay, we'll see what it's going to be. The first column is going to be as it is, and you already have the x plus y plus z whole square. Okay, this much we have. Now the first column is as it is, so we'll see how it is going to be. So the first column is 2y, z, y square and z square. Okay, here it was x plus z. I need to get rid of that. Here also it was x plus y. Then here 2z was there. 2z plus 1 by y times this. So 2 minus 2z plus 2z is going to be 0. Similarly, this is also going to be 0 because it is 1 by y. 2yz divided by z because it's 1 by z. So that is also going to be 2y minus 2y, that is equal to 0. So while doing this operation, these two zeros get disturbed and somehow we need to manage out with that. So this becomes y square by z and this becomes z square by y. Okay, that's all about the simplification. Now expanding, we have already got x plus y plus z whole square. Then we have 2yz. Now what is there inside the bracket is mattering. That is x plus z into x plus y. Then minus z square by y into y square by z. At last you'll get yz. I'm not bothered about that cancelling and all. So z square by z is z. Then y square by y is y. So y and z is going to remain. Yz is going to remain. So out of these things you have got 2 yz we got, and you have x plus y plus z whole square. Okay, one more x plus y plus z is remaining and one x is remaining. Okay, somehow we need to get that. So we have 2yz into x plus y plus z whole square into x square plus xz plus xy plus yz minus yz. Okay, yz and yz got cancelled. Now we have x common here. So since we have x common, we have 2xyz, and I remove this is x plus y plus z whole square. So what is going to remain in the bracket is x. If I remove from this, from here z will remain, then from there one y will remain. Okay, we got x plus y plus z whole square. One more factor makes it x plus y plus z whole cube. That's all about this long question. So we'll see what is first again. So the first thing was we need to multiply x to the rows and remove x from the columns such that we get only square terms. Okay, that was the purpose of getting that, because we have y square, z square and all, so we need to get somehow cancelled that. So the next thing is we need to get at least 2 of them first of all before expanding. So for that we did this. So we used the a square minus b square form, where a plus b plus c was equal to a plus b was x plus y plus z. Okay, in that format we went on, and a minus b terms were left out. So somehow I wanted to simplify the first column. In order to do that, I did this operation. While doing that operation, even these two terms I got, that is a simpler one. The next thing was I wanted to remove this minus y and minus z, or in other terms I can also tell that I wanted to remove this, that is minus 2z and minus 2y. For that I added with 1 by y times the c1 and 1 by z times the c1 for the first, second and the third column respectively. After that I got two zeros in one row itself, so directly I can expand. So it was going to be x plus y into x plus z, okay, minus yz, okay, minus yz. So this much was the thing. Now I expanded it, so it was going to be x square plus xz plus xy plus yz. That yz extra was there, so I just removed that by xy. Then we have 2xyz. Since x was common, out of that I removed that x out. I wanted xyz, so this much I got. X plus y plus z whole square was ready. So the thing what was common inside, I got that x plus z plus y, same as x plus y plus z. That's all about this example 32. Now we are remained with only the MCQs. Okay, now we have our MCQ questions, that is 17, 18 and 19, one more is there. So I have written the 17th question now. So the question given is A, B, C are in AP and you have to evaluate this determinant. The options given are 0, 1, x, 2x. So 1 cannot be there over there because x cannot be cancelled from everywhere, since we cannot see similar things over there. So 1 cannot be the answer. The other 3 we'll just check. Mostly one of them will be the answer only. So we have A, B, C are in AP. That means that by arithmetic mean we can tell that 2b is equal to A plus C, right? So you also have an example question like this, right? You have an example question, that is example 31, right? Example 31 is there, so you can just refer how you can do this question. So first I'll do. So I'm going to add R3. R3 becomes R3 plus R1. So I want to get this A plus C form such that I can substitute 2B over there, right? That's all about the logic. So I have C here and A here. So I'm going to add the third column with the first column, or I can add third column with the first. Row with the first. That's all about this. So the first column, first row becomes x plus 2, x plus 3, x plus 2a as it is. Then we have x plus 3, then x plus 4, x plus 2b. Then we have x. Okay, I'll remove 2 common because we will get 2x. And 4 plus 2 is 6. So I can write only 3 here. Again 2 also remain here, also we get 2 common, so it was x plus x is 2x, so x here inside. 5 plus 3 was 8. If I remove 2 outside, 4 will remain. Okay, similarly 2 here, x plus x, I got 2x here. Then 2b plus 2c plus 2a, that is going to be c plus a inside. C plus a I'll substitute to be 2b here. Okay, now I'll remove this 2 outside. Okay, here itself I'll do. Again I won't write the determinant, nothing waste of time simply. So I'll remove this 2, and write it here. Because I removed from one of the rows, I need to write it outside. So here I can find out that the second row and the third row, R2 is equal to R3. So the properties say that if 2 rows or 2 columns are going to be equal, then the determinant value is going to be equal to 0. So the option which says this is option A. That's all about the 17th question. Moving on to the 18th one. Here you have given a matrix and you are asked to find the value of the matrix A inverse. So you are given 4 options. You will see by solving from where we are going to get that. For that we need to find the adjoint of A. Adjoint of A is the inverse transpose of this. So since it is a diagonal matrix, only the diagonal elements will have cofactors. So the transpose also will be the same. I need not write transpose over there.
So here we get yz, here we get xz, here we get xy.
Okay, you can just try how you can do that. This is direct. If you take this, the cofactor is going to be yz, here it is going to be xz, for this it is going to be xy. That's all about this.
The determinant value of this is xyz.
Since I expand this in the first row of the first column, I can write it x into yz. Okay, that is xyz.
So A inverse is going to be adjoint of A divided by det A. Therefore, this is yz 0 0 0 0 0 xz 0 xy.
Okay, my matrix is going down.
1 by xyz. So each term I need to divide by xyz. So what will remain here is 1 by x 0 0 0 1 by y 0 0 0 1 by z. Okay,
This much we got. This is all the answer. This is going to be the A inverse. The option which is corresponding to this is option A.
option A.
Next, we have our 19th question.
Let me write the given matrix. That is 1 sin theta 1. Then we have minus sin theta 1 sin theta. Then minus 1 minus sin theta and 1. Okay,
That's all. You are asked to. All the options are corresponding to determinant value of this particular matrix.
so instead of writing this like this, I'll just write it together. Determinant value. Okay, the determinant over here, determinant value of A.
So I need to just calculate this. This is fully done. So this is based on sin theta. The value of sin theta, how it can be, it is based on the value of that. So let me start with the first row. I'll start. Okay, 1 into 1 plus sin square theta, okay, minus sin theta into minus sin theta plus sin theta. Okay, it's going to be fancy, everything is 0. Okay, next we have one more term, that is plus 1 into sin square theta, then minus of minus 1 is plus 1. Okay, it is going to be 2 into 1 plus sin square theta. Okay, thinking about the value of sin square theta, the maximum value of sin theta, modulus value of sin theta is going to be 1, maximum value. The minimum value of sin theta is going to be 0. So we are going to apply these two limits. Okay, not the limits in the next chapter. This is about the limits.
So the minimum value of determinant of A is going to be when this sin square theta is going to be 0, that is 2. See, this is going to be 0, it is 2 into 1, that is 2 only. Then what about the maximum value? Maximum value of determinant of A is going to be equal to when sin theta is equal to 1. Okay, when sin theta is equal to 1, it is going to be 2 into 1 plus 1. 1 plus 1 is 2. Again 2 into 2 is 4. Okay, that means that the value of the determinant, okay, I'll write it in proper manner, value of the determinant is belonging to the set of real numbers from 2 to 4 inclusive of both. Okay, that's all about this. So this is corresponding to the option D. This is all about the miscellaneous exercise in chapter 4, determinants and matrices by the very easy units. Next we'll go to the calculus, 5 chapters. Okay, thank you.